get started. All right, so first of all, let me give you a little kind of background information about Next Wave STEM. Next Wave STEM is a company that is located in Chicago, Illinois. I know I looked previously, most of the people in the room are from Chicago, but we do have some people from out of state as well, so welcome one and all. Next Wave STEM provides curriculum and professional development with emerging technologies to students and to teachers. Sorry, let me start over. Next Wave STEM provides curriculum and professional development to students based on emerging technologies. So we have curriculum in 3D printing, which we'll talk a little bit more about today, obviously, drones, robotics, and then we also offer professional development on those topics. Normally, under normal circumstances, I guess you can say, our professional developments would be in person. Like I said, our goal is really, we wanna empower teachers to give their students the best experience and be okay to fail without fear. And I like to say that I think teachers also need to have that as well. Obviously, under these current conditions that we're in, the webinar is the way to go. So that's what we're here to help you with today. So let's kind of get into this presentation. I'm so excited about this presentation today. 3D printing is something that not only is it changing the world, I know in the news and stuff, you've heard about PPEs being printed and just about like using the 3D printers to solve problems, or maybe in the medical field. But really, what's great about 3D printing is this idea of design thinking, or the design process, or NGSS refers to it as the engineering design principles. So we're going to start off today in talking a little bit about design thinking, what it is, and kind of want to give you tips and tricks to get you started with it. Then we'll talk a little bit about parameters when it comes to 3D printing. In a perfect world, we could print any size 3D print. We can use multicolors. We have an endless budget, but we know that's not the case all the time. And so what are some ways that you can limit the sizes and things that are being sent? So we'll talk about some parameters. And then finally, I am so excited to talk about ways that you and your students can visualize 3D printing, the prints, without actually physically printing. I think that obviously 3D printers, maybe they're locked in a room in your school, or maybe you are lucky enough to have a 3D printer at home or to have brought one home. But the amount of time it will take to print or to get those prints from your students in today's in the situation we're in today might be too difficult. And so there are some tools we can use that kind of bring our 3D prints to life. So we'll talk about that as well. As I said, we have a pretty packed session, and if you need me to slow down, I tend to get so excited about this and talk really fast. But if you need me to slow down, please put it in the chat. Desmond will alert me and I will go slower. So please, again. So let's get started with design thinking. And what you're going to see as we kind of progress through this, I'm going to refer to it sometimes as the design process and sometimes as design thinking. To me, they go hand in hand. The process or the thinking of how you're going to design something really is a way of solving problems creatively. And so I do apologize if I go back and forth, but again, it's kind of semantics. It's the same thing. And the great thing about the design process is this idea of it being user-centered approach. And so students, whoever's doing the building, they're designing for a specific user in mind and meeting the needs of that user. So kind of a little background, and I'm not going to read these slides for you, but I really think, I know sometimes we talk about starting a presentation with a definition, and that's great. But I am always one that wants to know, well, where did this come from and how did it get started? So just some background of this design thinking, this idea of thinking about how you're going to design things dates back to like 1969. And you can probably even pull some things from even earlier than that. But the when you do some research on it, they're going to say it at about 1969, where it really starts, and you can see it's pretty new. In 2005, jumping ahead, Stanford's design school started saying this is a way of teaching, like started teaching this process in a more formal method. And I would say probably around that time too, it starts showing up within in education. And so it really is, it really is something that is slowly evolving, or not even slowly, that's evolving. And we're seeing more and more and more and more uses within the education field. Now, design thinking today, when you think about design thinking, there are many different versions of it. So I had mentioned Stanford, and their D school, their design school, has a very well-known design thinking process or approach, and we'll take a look at that in a moment. But there are also, IDEO, which is a design. They also have their own phases. At Next Wave STEM, we went ahead and we kind of created our own process that we would like to see. But the bottom line is they all basically are the same. They embody the same principles and the same different processes. And as it says in the middle here, they range anywhere from like a 3-step or a 3-phase process all the way up to a 7. And I would even say there are some that go a little bit, they break down the steps a little bit more. So let's take a look at some of the design thinking processes. So Stanford's D school, their design school, came up with this design thinking process. And they divided their process into kind of 5 steps. Again, steps, stages. And what happens is you start over here at this, what they call their empathize step. And in here is where the designer, the person who is creating something, making something, building something, goes ahead and does some interviewing of who their user is. I saw something that was like, so think about it as if we take this idea of I'm going to design a car for Mickey Mouse. In the empathize stage of Stanford's D school, I would go to Mickey Mouse, or socially distancing myself, send Mickey Mouse some questions or hop on a Zoom call with Mickey Mouse and really find out what are the needs that Mickey Mouse has. And really writing everything down, really just trying to learn kind of where Mickey Mouse might have problems or not. And then after I've empathized with Mickey, I have no idea where Mickey came from, by the way. After I've empathized with Mickey, I move into the define phase. And this is really where, again, in the D school, I'm starting to break down what the issues are that Mickey says he has. After I'm in the define phase, I move into this ideate. And this is where I come up with thinking of all these different ideas, these things I can create to help Mickey out. And during this ideate stage, sometimes it helps that like maybe I go back to that user and I'm having a conversation with that user, and that user is constantly yes-anding me. Yes, and what about this? Or yes, and what about that? Then after that, I move into my, oops, I went backwards. Let's go back. Sorry about that. I move into my prototype stage where I'm going to create something. Prototyping is very key in the design thinking, present in the design thinking phase, design thinking process, because the process is kind of, it's a circle, or we are going to constantly change things. So we're going to prototype. I'm going to make an idea I'm going to take one of my ideate ideas, I'm going to build it. And then that last step within the D school is that test phase. I'm going to bring it to Mickey. Mickey's going to test it out. Did it work? Does it not work? And then based on that, I'm going to repeat again, make some changes and go from there. So this is kind of Stanford's D school process. And now, and you guys kind of had a quick peek of it before, the IDEO process. And in the IDEO process, and IDEO is all about design, and they have their design process into 5. And if you look at these 5, and I'm not going to take that Mickey example and bring it through, but I want you to look at it for a second. And I'm going to ask you, like, do you see those connections? And I'll flip back in a second to the D school so you can see D schools again. But in this IDEO's design phase, they go discovery, interpretation, ideation, experimentation, evolution. And so take a look at that. And do you see how, hopefully you see that those 5 stages have a lot of similarities if I jump back to the D school's 5 stages. And it's the same basic ideas with maybe a little bit more questioning. You can see in IDEO, they have kind of like, I have a challenge. How do I approach it? I learned something. What do I do to interpret it? So again, it's this questioning, and it's this, again, user-centered problem solving. So I'm going to pause for a second. And that was a quick kind of overview of design thinking. And I want you to think, and I'm going to ask you if you would like, and I would appreciate it if you would, to kind of put into the chat, when we look at those different, and I'll go back to the processes again, when we look at those 2, IDEO and design thinking, and thinking about it as it's a process to design something, and what types of things would you include in that design process? So what steps or what phases? So you have that build, and you don't have to have the same names. I'm going to pause for a second to give you time just to think about that. And if I come back here, here's an example, again, back to IDEO, is what steps you would include. Think about, or even if you're having some difficulties thinking about things, think about think about a problem that you want to solve. And we've all done problem solving before, right? I'm stuck at home. I need groceries. That's a problem. That's a big problem. What do I do? And how might I be able to work through problem solving and solving that problem? Katie said research or history of solutions to what the problem is, to whatever the problem is. And research is great. And that fits into, sometimes that fits into in IDEOs, the interpretation stage. A lot of times you do see the research. I love the idea, Katie, that you put in history of other solutions. I'm a big proponent of saying, why should I recreate, like, why do I need to recreate the wheel if someone's already done it? So it is really important to do that research, see what's already been done. And I would even push it that step further within the problem solving to say, if you see what's already been done, what history, maybe now take what someone else has done to solve that problem, and how can you adapt it or change it is also really big. And what you'll see, and feel free to add as we continue on, but thanks for sharing. At Next Wave STEM, we went through and we looked at design thinking from D School and from IDEO, and all these other places to see kind of what we felt were the main points. And Tesman and actually sat there on a whiteboard, and we kind of like planned out, we came up with a problem, and we kind of put it through steps to see how we would solve it. And we came up with this. And this is kind of our main, we say this is like our 6-8 focus. Oh, yes, Nicole, thank you. And I should have mentioned that before. You definitely can relate this to the scientific method. And like I said, so scientific method, design process, design thinking, NGSS, engineering design standards, they kind of all have those similarities to it. So thank you, Nicole, for reminding me about that. So this is the process that we came up with for grades 6 through 8 is kind of our focus ages for this. When we talk about 9 through 12, our grades 9 through 12, we kind of get a little bit more high end and dig a little bit more deeper into these steps. And then as from like a lower 3-5, or even if we do K2, we would break these steps down smaller. So we would maybe only have 4 steps within the 3-5, and then maybe even less steps, 3 steps within K2. Again, just kind of pulling out the different things. So here we have the design thinking process that we have, and you'll see again, hopefully you'll see similarities between D-School, IDEOs, to Nicole's point, the scientific method. And we really tried to make them compact and simple. So they have an image and the word. So ask, imagine, plan, prototype, test, and reflect. So we're going to kind of just take a little walk and dig a little bit more into these different ones. So we start with the ask phase. And the ask phase here is really coming up with what is the problem you're trying to solve. And I really like to say, turn that problem into a how might we statement. So I'm thinking of my house right now, and I'm thinking of being in my house all the time, and I love flowers, but I don't have flowers. And how do I add joy into my house and freshness? So my problem that I might want to try to solve, and I'm going to try to take this problem through the rest of this presentation, is how might I design something to add joy into my house since I'm stuck inside all the time? And during this ask phase, I might also think, what are the constraints that I have to deal with? Well, I'm stuck at home. I only have a 3D printer at home. See where I'm going with this. I'm going to connect it back to 3D printing. I only have a 3D printer at home. So I want to design something I can use my 3D printer with. So after I have my ask, my how might we statement, I'm going to move into the imagine phase. And in the imagine phase, this is like the brainstorming. This is where I'm going to brainstorm solutions. I'm going to do, as Katie had mentioned, like the research, what has been done. I might interview my husband, talk to him about what he thinks can bring more joy. Like, what can we add into our household, right? Maybe I'm going to bubble map it. Maybe I'm just going to make a list. So there's a lot of options here as to how you want this to look in the imagine stage. But it's really, I'm just going to write down ideas, and I'm just going to imagine different things. And then the third step in our process is a plan. And this is where I am going to create my blueprint of my design. So I looked at my how might we, I imagined it, I came up with ideas, and the idea that really stuck out for me in my example, let's say, is I'm going to use the 3D printer to design a vase and a flower in it to add. So it'll be a 3D printed flower. And so I'm going to draw it. And I think it's really important here to draw and to label the design. So things that that I want to make sure, I'm going to maybe label the sizing. How big do I want it to be? How tall do I want it to be? I'm going to label the different parts so that in my next phase, which is the prototype when I'm actually going to build it, I can look at my plan and then transfer it to my 3D design. So if you think of it as your plan is your rough draft, your sloppy copy, whatever you want to call it, and your prototype is your final copy, even though it's not so final. And then I'm going to think about in the plan, like, what materials do I need? What do I need to make sure I have in order to execute the plan? So I need to have a 3D printer, or I need to just have a design. I need to have access to a computer so I can design it in CAD. And I need to have my blueprint that's going to tell me the sizes. So after I have made my plan, I then move into the prototype stage or phase. And so prototype is where you're going to build. And if you've noticed as we've walked through the steps, I'm visual. So not only we have that word prototype, but the hammer and the screwdriver, because it's the building stage. And because this is 3D, I'm talking 3D printing. My create in this case is I'm going to use Tinkercad to create it. But if you're not going to do 3D printing, which is fine, and you want your students to take something through to the design process, maybe their prototype is to build with cardboard boxes, right? So it can be anything really. After the prototype stage, I've now created it. I have to test it out. And so I take that prototype and I test it. Did it work how it was supposed to work? If it didn't work, what didn't work? And then also, how does it compare to the plan that I created? And then the last step in our main process here is the reflect. And I think this is key. And I think sometimes we are so quick to get something done that we don't take time to reflect on anything, our processes or whatever. And so there's two types of reflection here. First, reflecting on, like, how could you improve your design? How could you make it be better? And this is where that how you can make it better loops back around, because how you can make it better and what changes you can make, or how you can fix it if it didn't work when you tested it, becomes my new ask. And then I'm starting that process all over again. And it really is something that you can just get caught in a positive way in a loop of constantly making changes and making things better. But then you can also take some time here and reflect on the process and reflect on what can you do differently next time. Also pulling out, and this is, when I work with students, like, what are you most proud of within this design? Or if you worked in a group, how did you guys work well together? And if you didn't, or even if you did, what could you improve on next time to be a better group, to be more cohesive? So again, it's this process that goes through. So I think I'm going to pause here for a second. I went quick, but I want you just to think about it, and I'm going to pause and see if anyone has any questions on the design process or the steps in the design. Again, feel free to drop them in the chat or drop them in the Q&A and go. The other thing I want to ask is, can you see how using the design process could be useful with your students in ways that you can use that to solve any problem, not necessarily with the 3D printing? Pause for a second. Okay, I'm going to continue on, but again, feel free to enter things in the chat, and we will move on. So the second part of this presentation, and it's one that, again, there's so much information here, but I think it's really important to kind of take a step back and think about it, is establishing parameters for 3D printing. And there's limits on what can be done. So the first thing that are good questions, you know, maybe information to share with students if you will be 3D printing on a 3D printer, is to think about the limits of the printer itself. And what do I mean by that? Well, I mean, how big is the 3D printer? So how big is the print bed? So the print bed is what your 3D print will print on. So, you know, I've seen print beds at our office when we were all together. We had a print bed that was probably, you probably can't see my hands fully, but we had a print bed that probably was about 4 inches, maybe. It was a smaller printer around. And so that was something that when we would 3D print on it, we would need to really remember that. So we couldn't make anything that was bigger than 4 inches wide, or yeah, wide, lengthwise, wider length. And then we also have 3D print. We also have to think about how high, like how tall can something be? And so there you have some math that you could do. You could put it on your students. Here's our printer. What's the print volume of the printer? How big of a piece? And then also to then take those printer limits and think about the measurements that you're going to create within, you know, I'm going to make a vase. If I think about it, a 10-inch wide vase is pretty large. And so let's think about making those measurements. I wrote, are the measurements correct, but are they standard, and do they make sense for what you are creating, and then that can fit on the printer? And in Tinkercad or any other 3D design software that you're using, you can do that simply by using the ruler or by using the other measurement markers within there as well. So the other thing to look at, and if you joined us last week, we talked a little bit about infill. And infill is basically it's the filament that's used on the inside, not the walls. So if we take this eye here, sorry, the walls of the eye, that's the walls. The inside is what's considered infill. And so something else to consider, and this could be a constraint that you give to students, again, or just these parameters that they have to print within, is the print time. So here on this image here, I have the same size letter I, and I've changed in my slicer settings it to 3 different infills. And what you can see here is that the amount of infill, which is the amount, so 0% infill means the eye is hollow, where 100% infill, it's a solid on the inside. You can see how the print time for the same shape changes based on the amount of infill that you're using. Again, that's something that's done within it's something that's done within a slicing software, but it's also something that's really important to kind of explain to the students as well, because that affects the print time. Along those same lines, the amount of filament, or the PLA in this case, that's used is directly affected by the infill settings, which makes sense because if the eye is hollow, it's going to use less filament than if the eye is a solid. So you can talk to students about that and give them parameters around that, constraints around what they have to work within. And then my last kind of parameter that I think is kind of an interesting thing to look at is looking at cost to 3D print. I know when we're in a live professional development session with teachers, sometimes we get asked the question, well, how much does it cost to print a standard print? I'm not quite sure what standard is, but how much does it cost to print? And it's a hard kind of question to answer because obviously size and infill and everything we have discussed earlier kind of plays into it here. But you could do a little math exercise with students. And so I'm not gonna, I see I'm kind of short on time, so I'm gonna kind of move through this quickly. But talking about the cost of the filaments calculating the cost of the 3D print. And so here's a little math where when you have a cost of a filament spool and you have the weight of a filament spool and you have the amount of filament that you needed that you got when you did your printing, and that is information you can find within your slicer, you can then go ahead and do some math and figure out the cost of the filament. So here is an example. If I was printing the eye at 20%, the amount of filament, the cost of my filament, and doing a little bit of math, I can find that to print the eye with the settings was 21 cents. Right? So again, adding a little bit of math and kind of changing it around a little bit is kind of another parameter, another constraint that you might want to share with students, or if it's not even a parameter, a great exercise for students to be able to figure out how much their 3D print costs based on that. So again, lots of information, lots of things to consider, and stop me, ask questions. So now the super exciting part, the whole thing's exciting, but visualizing it without printing. So I'm gonna do some switching of screens here. Again, I went through that quickly. I see that Katie said that when teaching STEM, we usually teach everything using the scientific method, which this is great, slightly different way to teach it than an experiment. And I think that is super key. The scientific method, more for science experiments and along those lines. But if you really take that time to talk about the design process and kind of switch it, they go hand in hand, but they also kind of hit different key points along the way as well. So, and I'm also glad that you find the reflection useful. I think that I remember when I was in college becoming an educator, and we had to reflect on our teaching that we would do. We videotaped ourselves and had to reflect on it. And I'm going to be honest, I didn't really like that, but I learned a lot from my reflections. And I think if we get students to reflect more is key, and reflect on those failures too is really important as well. And Nicole, thank you as well for commenting. Definitely, if we can connect them to everyday concepts like cars, phones, and video games. And it's interesting when you talk about cars and phones and you talk about like progression over time and progress over time, and how things have evolved over time. And so if you really look at the idea of like even a cell phone, right? Cell phones are everything from, you know, a flip phone to now to like the smartphones. Funny that the flip phone is coming back again, but they've all solved a problem and they've all improved on previous iterations of it. So that's the iterative process is key as well. So I'm going to switch my screen. Thank you for sharing. So I want to first start here. I'm going to start at the Tinkercad stage for a second. So I had mentioned when we first started that the design thinking, I was thinking about like what I could kind of bring through the design process. And I thought to myself, I would like to design something that brightens my house. And I love flowers. And so I went ahead and I created in Tinkercad, and I'm just rotating around, a flower pot with one flower in it. And let me switch. Sorry, I'm trying to move my screens around a little bit. All right, so I went ahead and I created this, and you can see, and when I talk about my planning of it, I might choose to plan, and especially if you're going to use 3D printing, have your students kind of shape it out with what shapes they could use to build their object. So you see I have a cylinder here. The stem of my flower is also a cylinder that I like smushed. And then I used when I made my flower, I used the half sphere and I used the round roof. And I did a lot of rotating and to get it to stand up and stretch. And so when I have this within Tinkercad, I can view it in 3D. I'm going to show you that in a second. So when I click through my dashboard, right down here, I do have a button that says View in 3D. So I'm going to click on that view. And here you can see I'm viewing it in 3D. Very, very similar to when I was in the actual Tinkercad work pit plane. And I can see it. But that's one way I can view it. And that's great. But I think that's fine, actually. It's not great. It's good. It's fine. I can take a look at it. But I came across two applications that I think you're gonna like. The first one is if you are using iOS app on a mobile. So it's not, I'm on a MacBook now, so it doesn't work on the Mac. But if you're in iOS mobile, Tinkercad does have an app, and the Tinkercad app has augmented reality. And in augmented reality, just a definition about what augmented reality is. Augmented reality is basically I can bring objects into my real world via my mobile, via my phone, and they can show up. And I'm going to show you that in a moment. And so Tinkercad for iOS is great. But I have an Android. So I went looking for something that would work on my Android. And the one that I came up with, the app, which I'm really excited about, is called 3D Bear. And it works on iOS or Android. So now we're going to hope that this works. So give me 1 second to switch to my phone. And while we're there, if you weren't at the first, so Tinkercad is just the website that you can build the 3D, you can build in 3D, you can design in 3D. And then the Tinkercad, and that can be done on a computer or on any device. The Tinkercad app on an iOS device allows you also to do this augmented reality. And, okay. Right, hang on. Hold 1 second. I'm going to switch. And then this other app, which is called 3D Bear. All right. So I believe you can see my screen now. All right. So you can see my phone right now. And I'm going to go to the 3D Bear app. It's called 3D Bear. And open the app. Now, as it's opening, from Tinkercad, I took my design and I exported it as an OBJ, an object file. And then I moved that OBJ file to my phone. I ended up emailing it to myself, but however you do it. So now I'm in this app called 3D Bear. And I'm going to click this three-dimensional, there's a prism and a cube circle right in the middle where it says create. All right, so now you can see, my, my tray that I'm going to be putting my flower pot on to show you what it looks like. You can also see my house, so welcome inside my house. And so I need to add my 3D design here. So I'm going to click, where did it go? Hang on. I'm going to click again the square or the cube and triangular prism. And I have a choice of what I want to import or what I want to use. And just as a quick side note, there's tons of stuff that's already built in, but I want to take my OBGA, my Tinkercad file that I have created, and bring it into my house. So I'm going to click the plus sign, and I'm going to scroll down. And here you can see it says imported models. And this is where I'm going to click the import button and then find where I have it downloaded and put it in. I've already done that, so I'm going to click the file. And what should happen? Oh, all right, let's try it again. All right. So the object, you can't really see it right now. It did come in. I'm going to click the checkbox. So now I can move it up. Can you guys see my flower pot? And it's obviously right now laying on its side. For some reason, I've noticed that it brings things in the wrong way like this. So I need to rotate it. So I have a rotate button. And you can see I'm rotating it. And then putting it in that area where it is on my desk. Now, it's hard to see because of color, so I can also give it a different color. So I have kind of like pink flowers. And I could, I think, I'm not walk around it, and you can see it as it's as I walk around it. And there are some other, I moved it over, so it's actually right now sitting on my tray. And again, I can interact with it more. I'm connected via my headphones and my computer, and if I got up, it would be a disaster. But you can see I can move around. I can add more things to it. I can import and really kind of get a look for what it looks like. And I believe I can even, said this before too, I can change kind of the sizing of it too within this real world environment, this augmented reality environment. I think this is a really interesting, really great way to see the objects within a setting that you might want them in. And I can so I just took a picture of it, which then I might choose to send to my teacher or upload to Flipgrid, do whatever I need to do with it there as well. A really interesting way, I'm gonna pop off of this for a second. All right, a really kind of cool way to see your design within this 3D printed world. I'm not sure what just happened. Hang on one second. Oh, okay. That looks good. Sorry about that. So to see your design within to see your 3D design within your augmented world, within wherever you want it to be. And I think that is really something that can interact. And I know when I was doing a little bit of research within this 3D bear, I saw that you could there is a way, I don't know if you saw it on my phone, but there is a classroom setting. And so my belief is you could make a classroom and invite students to it. Also, I just found out when I was testing this earlier today that there is a button that you can invite someone else, like share a link with someone else. I think it's within the classroom. And so multiple students could work within the same augmented reality world to drop in their 3D designs as well. So really neat, amazing technology that I think is only continuing to get better. So I hope if you guys give it a try, let us know. Like I said, I think the future is super bright. We might seem a little, I'm in Chicago, it got cloudy again. It might seem a little cloudy or shady, but the future is super bright, and how cool to be able to take designs and bring them into this bring them virtually into your house when you can't maybe physically 3D print them, is really cool. And I was just also remembered, I wanted to point out, I had mentioned this last week during the Tinkercad PD, or sorry, during the 3D printing PD, but wanted to, sorry about this, moving a variety of different things around here. Wanted to just give another kind of quick mention that within Tinkercad now, they have a making at home. So I think that from like a design process, this could be really interesting to see, is perhaps a constraint that you give your students to create something, design something, using everyday household items that they're going to have in the house. Maybe it's I was just kind of thinking of this at home today. Maybe it's using paper towel rolls to drop a that you tape on the wall or tape somewhere, and then drop a marble, like a marble run with the paper towel rolls, or paper towel roller coaster. So using paper towel rolls and plates to create a roller coaster, and maybe using the design process and using Tinkercad and 3D building, and students can prototype what it might look like. So they can bring in the toilet paper roll. I mean, how great is that? They can bring in the toilet paper roll, and they could create with the toilet paper roll, this could be part of the plan. The Tinkercad could be the plan for prototyping it. After they've thought about it in their mind, then they can use Tinkercad to design it. Maybe then they could take it and, using 3D Bear or Tinkercad iOS app and augmented reality, bring it into their house to kind of see what it would look like, and then actually go ahead and build it with the actual supplies. I think that could be a really interesting and cool use of this. And I'd say if anyone takes me up on this idea, share and come back and tell us how it went, because I think that could be super awesome. And let me switch back to my presentation. Again, if you have any questions, please feel free to drop them in the chat or in the Q&A. I see that Desmond's doing an awesome job of sharing some links to the Tinkercad iOS app and the 3D Bear app as well. So thank you, Desmond. All right, so we talked about visualizing without 3D printing. Again, the augmented reality apps. And as someone asked earlier, and Desmond had said, you will be getting an email with links to this presentation. So it was there. And I want to kind of like bring it all together and kind of go back to this idea of next wave STEM ourselves, and just this idea of using the design process and all of the ways that by using the design process, 3D printing, augmented reality, hands-on building, reflection, I mean, we could go on and on, that we are really further building and supporting 21st century skills and NGSS standards. And that is what makes me so giddy and so happy about using all this stuff. Really that creativity and, even a little bit of that collaboration. I think that trying to get the collaboration piece in when everyone's in their own house is sometimes a little bit, it can be difficult. I'm not going to lie. We're all becoming creative as to how we're going to collaborate with other people. And like we've mentioned, being on Zoom calls as adults or having conversations or with people or playing games online is kind of our new norm of how we're working on things. And the collaboration within building, creating something and bringing it through the design process. And maybe it's even just like sharing the steps that the students can do. via Flipgrid, via jumping on a Google Meets, or maybe sending emails back and forth. But that collaboration and the being able to yes and as you're taking something through the process further develops these great 21st century skills and NGSS standards, and really prepares the students for what's ahead and this idea really big solving problems and how to work through those different steps is super key as well. So just a little bit on that, which also then I guess I would say like brings us back to Next Wave STEM and giving and are really wanting to be able to provide the resources and help not only the students with these emerging technologies, but also faculty and adults with how to best use them. So here, where do we go from here? You're probably wondering, or maybe not, but I'm going to tell you anyways. Where do we go from here? So we, like I said, Next Wave STEM, we have curriculum in 3D printing, robotics, drones, and artificial intelligence. And we also offer equipment bundles and professional development. And so really we're kind of like a one-stop shop, all-in-one solution. So I invite you to check out our website, nextwavestem.com, to kind of, I went ahead again, nextwavestem.com, to check out our website, see what we have to offer, and see like how we might be able to help you in creating more and building more and giving and providing your students with more resources with using the emerging technologies. Also, for attending today, if you are in Illinois, you can get the ISB PD clock hours, the 1 hour. So you'll be receiving an email from us later today. And in the email will be a link to a survey to fill out. And then you will receive your certificate for the 1 hour time. Also within that email, we're going to send you a link that you can sign up and access our curriculum for free, our 3D printing curriculum and our drone curriculum for free. And take a look and, start using it with your students. That would be awesome and great. And then we will also send you a link to today's presentation along with the slides from today's presentation as well. Finally, I guess I encourage you to check out our other professional development that we are offering, webinars, on our Next Wave STEM professional development website. As I mentioned at the top of the hour, we've kind of designated Tuesdays as webinars for drones that my colleague Desmond will be running. And then I'll be doing the 3D printing ones on Thursday. Next week is a repeat of this session. But if you want to come back and I probably won't trip over my words as much as I have today because I've done it once. But yeah, check out our professional development webinars. And also we do, when we can get back to being around people, we do the in-person professional developments as well. And then finally, connect with us on social media. We're on Twitter. We're on LinkedIn, we're on Instagram, we're on Facebook. One day I'm gonna get Desmond to do a TikTok. So, who knows? Times are crazy, so I guess we have to jump onto all those different social media. No, but seriously, we are on social media and we love it. And then also feel free to reach out to Desmond or myself. You can see our emails up here. We really want to help you, and we help you from a distance. We want to provide resources where we can provide resources, troubleshoot with you if you're having any concerns or anything. Again, we want to be a resource, a key resource for you. So feel free to reach out to Desmond or myself. If this is something that after you take a look at your curriculum, or even today, you're like, I need to find out more information, this would be great for our schools. Our school partnership manager is Jared, And I'm sure Desmond's going to be typing in his information in a moment, but you can reach out to Jared and we can see how we can further partner with you, be it training all the faculty when we get back to school, being able to be in school, or providing you with more curriculum that you can use, or even if you're in the Chicagoland area, possibly we have some mentors who can do some teaching on the STEM topics. So again, please feel free to reach out to us. And yeah, wow, that was a really fast hour. And again, apologies if I went too fast. Feel free, as I kind of like wrap it up at this very end now, if there's a question, something you missed, something you want me to mention, drop it into the chat. Otherwise, thank you guys for joining us. And the sun came out again in Chicago, so it's a good thing. And have a great rest of the day. Thanks. All right, I'm going to end the meeting, but if you have any questions, please feel free to reach out to myself or to Desmond. Again, thank you again for joining us. Katie, I just saw your message. Feel free to reach out to Desmond or myself and we can, see what you're looking for. And we would love to work with you and try to figure out what we can provide to help work with the students or the youth.